In TechNote 005 I demonstrated how the ESP8266 can operate as a standalone web server controlling LEDs, a relay, and reading data and images from the SD card, the micro SD card. And I was using the WeMOS shields, so the WeMOS ESP8266 plus some plug-in shields for the micro SD, a DHT 11 temperature sensor, temperature humidity sensor, and a relay. So now what I've done is create a full-size web page, and I've got the little web server up and running, so I'll pull that up now and just give you an idea of performance. First of all, I've added a routine to read the contents of the SD card, and there it is. Every time it sees a directory, it actually reports it's a directory and then the contents of the directory, and these are all the files that are in the required to operate the website, the test website that I've put onto the card, back to the home page. So let's have a look at the test site. So I've called it it's a default or a blank test site, and there it is. And it's got the usual, you can change the logo, you can change the headings, there's Latin random text in the sections. It's actually produced by Microsoft Expression Web. It's the default, no changes made. So you can I'll just give you an idea of performance: news, products, services, calendar, contact. There's some additional links down here that don't show up there, a section on employees, employment, information links, a photo gallery, and obviously photos could be added there, a press link, promotions, and a sitemap. So there it is. That's a test website running on an ESP8266 that's essentially a web server, and there's an idea of its performance. And that website could be just change the text in here to be whatever you want, and the little ESP8266 can act as your web server for you. Now I'll go through I'll do a code walkthrough. And so this is the software that's programmed on the ESP8266. I prefer the WeMOS D1 Mini, but the standard ESP8266-12E low-lin type board, development board, is just as good. All you've got to do is remember to select the right board, either a generic 8266 module or the Node MCU 1.0, the -12E module, or in my case this D1R2 Mini or Mini. The only difference that makes is the pin nomenclatures. So D1, D0, D1 is mapped to GPIO whatever on the board itself. So if you get that wrong, your devices won't work. So you do need to select the right board. So first of all, these are the libraries required to operate the server. Because I'm reading temperature from the DHT11 shield, for this DHT library here, you need to define the DHT type, and I've chosen DHT11, or there is another shield which is the DHT22 shield. You'd put that in place of that. Which pin is that connected to? Well, the default for that shield, that board, is pin 2. Similarly for the relay shield, that's pin 5. Then the library itself needs a logical name assigned to it to tell it which pin to use and what type to use, and that's what that expression there is doing. Define some variables for their floating point. They don't have to be, because the DHT11 is an integer result, but you can use the 22. A floating point variable for humidity and temperature. A general purpose string variable called the web page. That will be the page actually served out. The DHT sensors aren't that accurate. They do need calibrating, and so I define some temperature and humidity offset errors, and you can see the extent to which they're off. For your network, you need to put in a SSID and password. Next, need to establish a server address. I've used port 80. So when the ESP connects to the network on this particular USB port, it always connects to IP address 42. So 192.168.0.42, and if you don't change the port number, you don't need to explicitly reference the port number on the address. Now I'll put an example here. If I put 55545s in there, I'd have to address it as, in my case, http://192.168.0.42 port number : 5555. If you leave it at 80, you don't need this last part, and the default is port 80 for a browser. Set up some variables for SD card reading. Is there an SD card present, and what file is being requested to be served back to the client? That's that variable there. Set the serial port up to a baud rate of 15200. Begin the Wi-Fi connection with the SSD and password that were defined up there. Begin the DHT reading process. Give it a short delay, and I found it useful to just do a quick read, initial read, because sometimes you get unknown values come back. Print out some diagnostic. This will actually print the IP address down to here, so these are just diagnostics, and eventually it'll print out the IP address that's been assigned by the DHCP server. Next, it defines in the setup routine here, in the setup, it defines what's going to happen when it receives a client request. So if I typed in my browser line http://192.168.0.42/LED on, LED on would be the text that's supplied to the server, and when that's received, what should it do? Well, it should call the subroutine called LED on. Similarly for LED off, relay on, relay off, and you can add more in there obviously to do different functions. If you put a directory on the end as a parameter, you'll go to the directory function and print the directory of the SD card. Similarly for DHT readings, or do an update. That one's that special case where it actually writes the temperatures to a file, and then the web browser actually displays the file. Handle error if the address isn't found. That's that function there. And then actually start the web server, and then sit in this loop waiting for a client to, is the main loop of the program, waiting for a client to connect. And if the client connects, the server will then act upon, first of all it will display index.htm, and then it will wait and act on these events here. So those are the events it will react to. One of the first routines you'll see here, subroutines or functions, first of all update the temperature humidity variables with the current temperature. So that calls another function. Append a web page header. Rather than keep repeating a web page header or the HTML required to correctly format a page, the string web page gets a set of HTML codes added. Well, what I'll do is I'll go straight down there and let's have a look at that. So this is here, I put in those comments, this is a correctly formatted HTML web page. So what this is doing is beginning the structure of the page. So all of this text here is added to the string, the variable called web page, and its web page as a quite large string variable is parsed to the client. So back up to the top here. So the function I'm defining is update the temperature, update and display the temperature humidity. So get the latest values, append the header, and then append text specific to this function. In this case it's DHT11 readings. Add the readings to the temperature is a integer value of temperature converted to a string, so it's of the right type, and that's degrees C in HTML, some no break spaces, same for humidity. Then add a footer section, and then actually send the variable called web page over to the client, and that sends a correctly formatted web page. This is the function for reading temperature humidity. That's the one that gets called there. This calls this function here, and it's quite straightforward to read temperature humidity. If there's an error, then send a diagnostic to the serial port. Similar way for LED on. Append that header, append some unique text for switching the LED on or off, and call page3.htm. Don't have to call a separate page, it could all be done in this section here, but I chose to do it as a separate function, separate page. Send that text to the client to say the LED has been turned on, and then actually switch it on. So for completeness, I always set the pin mode of the LED output, actually write it low because it's active low, wait a second, and then send a diagnostic to the serial port. That's not seen in normal use. Similarly for LED off, the only difference is writing that pin high rather than low. And a very similar function for relay on, and again the relay pin is set high or low. There it is, set high for on and low for off. Display the directory, and what happens here is that it's a /, so it's directory /, which will show you the contents of the whole card, and append the header, some specific text to say this is a directory listing, and then rewind the directory or reset directory to the top of the directory tree, and then print the directory contents, and then send it over to the client. That same web page variable each time. Okay, so this is the function here that prints the SD directory, and the file name is /, and if there's nothing there, then break out of the routine, nothing to do. Add some HTML for a table row, and append the name of the file that's been read from the SD card. Put in a space and close the table cell. And if it's a directory, say print this was a directory, and a / denotes a normal directory nomenclature. Then recursively call itself, and start again. Keep appending to that web page variable each time, and then when it's got the name, then close the cell, go to the next cell and put in the file size, and until the directory has been processed. And eventually, when there are no more files to process, the function is closed and it returns back to the calling function. This one is, so if I send the command display a .htm or display a JPEG file, first thing it does is find out what the file name type is. So it's looking for a file type. Is it index.htm, or does it end with .htm, HTML, CSS, Java, PNG, GIF, and so on? So it's selecting, so if it's a JPEG, it's selecting the right data type to tell the client's browser how to process the returned data. Opens the file here, and then serves the data file back to the client, by setting up a classic HTML server response. So all this is doing without going into too much detail. Handle a file not found situation, essential. This function is parsing data to the SD card, and so what it's doing is creating a file called temperatureHumidity.htm. If it exists, remove it and then create it. So it overwrites. I found that that's more reliable than overwriting the file. Get the latest temperature, humidity, send some diagnostics, append that web page header as usual, apply the unique text for a web page, for a display page. So it's actually what it's doing is copying the function that would ordinarily send the HTML directly to the client, except it's writing it to a SD card. And then when you call it temphumi.htm, it actually displays the same information, but the key difference is temperature, humidity are being written to the card. Close the file, and then send the text. And there it is. That's the one we looked at as a function to append the text. So that's a walkthrough of the full server. Essentially, it spends most of its time loading from SD card, if it's the test web page, processing each file type as it finds them, and then sending the file and the file descriptor back to the client, so the client's browser can read and act upon the data that's being sent back. So there you have it, folks. That's a complete a fairly detailed walkthrough of the ESP8266 web server.